Hello everyone. Today we look at an in-depth view of the development length and its importance in construction. Now we try to make it as simple as possible so everyone can understand. So let's get into it. Hello everyone. Today we look at the development length. In the previous tutorial we were looking at the bond strength and the development length briefly is just this length that you see from here to here. Now you see this is our beam, this is our pillar or the column. Okay, now of course in the beam and the pillar you always have rods now. So this is a rod, this is another one, and these are the rings or the stirrups that are holding them together. Now the development length is this length that is, now this beam comes and ends here. Okay, see that this beam ends here when you're looking at it externally, but the rods do not end here, they continue like this. So it is not like this. This is wrong, this is correct. So the rods actually extend and come in like this. So this extension of rods, this coming down like this is what we call the development length. Also is the same here. So the development length is just this extension, or are the extensions that form an accurate bond strength, like what we looked at in the last tutorial, thereby giving this structure a safe passage of the load that is from this beam to the column, and then from the column to the ground. Okay, now the development length normally is this is the formula LD, like you see there. Here LD should be that the development length should be greater than or equals to, it must be greater than or equals to, okay, shouldn't be less than, must be greater than or equals to 0.87 multiplied by Fy multiplied by pi, all this divided by 4 times the bond strength. Okay, I'm going to explain this. Okay, all right. Now Fy is what we call the yield strength of the rod or of the rebar. So Fy is equals to, that is equals to what we call the yield strength. What is the meaning of yield strength? If you have your rod, let's say diameter 12 rod or any diameter, and it is say FE 500 or FE 400 or FE 450, depends. When you see this value 500, that represents the yield strength. Okay, so in this case it means that the yield strength of this rod is equals to 500. It is measured in newtons per millimeter squared. Okay, so that's just the yield strength. So if the rod we were talking of here was FE 400, it means the yield strength will be equals to 400 newtons per millimeter squared, and so on. Okay, now pi is just the diameter of the rod. Okay, so this is equals to the diameter of rod or stirrup. And in this case, since I was speaking of rod 12, it means that pi is equals to 12. Okay, now 4 is a standard number, and then the bond strength now, which was what we were looking at yesterday. Now this bond strength is given by, first of all, let me briefly explain what the bond strength is again. Now let's say you have your pillar like this. Okay, and of course in this pillar you have the beam which projects out like that. Okay, now if you have a rod that is embedded in this beam like so, and you try to pull this rod out this way, say by force T, now you see that there's going to be, let's say the rod is there, there's going to be a frictional force which will be exerted, now preventing you from pulling this rod out. Okay, now that force, not really a frictional force, but that force is what we call the bond strength. Okay, and of course this bond strength really comes about from by looking at the type of concrete that you have here. Okay, as you know, we have different types of concrete. What do I mean by that? By the type, I mean the quality. Okay, all right, so let's say, like for instance, if we are working with let's say M20 grade of concrete. What does that mean? M20 grade of concrete, that means one part of cement to 2 parts of sand to 4 parts of gravel. Okay, so if we're working with M20, it means that the bond strength here is going to be equals to 1.92 Newton per millimeter. Okay, and if we're working with something like M25, the bond strength will be equals to 2.21. Of course, we'll mostly be working with this, so let's use this for this example. So it means our bond strength here is equals to 1.92 Newton per millimeter, just like that. Okay, now so let's say after you have all these values and you sum everything up and you discover that at the end of the day your development length LD is greater than or equals to, let's just say 300 mm, that's 300 millimeters or 30 centimeters. What does this mean? This means that when you come to your beam and you are doing your connections, your development length, which means this extra length of rod, that is when your rods come and terminate here, you have to prolong them. So this extension that you prolong to now come out and go down like this, just like what you see here, and also this other one that also comes out and goes up. After you do your calculation, it should be greater than or equals to 300 mm, which means 300 millimeters is 30 centimeters. It means when you measure from here to here, it should be 30 centimeters or more. It should not be less. Okay, so if you were to measure from here to here and you see that this is like 20 centimeters, you know that there's a probability of this beam failing. If you were to measure from here to here and you see that it's 40 centimeters, then you know it is okay, because you've provided more than the required length. That is why you see, let's say here, it should be greater than or equals to 30 centimeters or 300 millimeters. Okay, so basically that is just what the development length is. And again, I explained this in simple terms. The only thing that you need to do in order to bring out development length is just to know this formula. Okay, so you can even do this on paper. It is very easy. All you need to do is 0.87 multiplied by Fy. What is Fy? Fy is the yield strength. So if you're using rod 400, you just put in 400 here, because that is going to be not rod 400. If you're using Fe 400, okay, that's the strength of the rod. You put in 400 here, and then you multiply by the diameter of the rod. Let's say if it is diameter 8 or diameter 10 or diameter 12, you just put the diameter here. Okay, and you divide this by 4 times the bond strength. And of course, the bond strength, now you are going to know the kind of concrete mixture that you are using on site. If it is 1:2:4, it means that is that is the bond strength for M20. Okay, and it means that at that point now you are going to use what? You are going to use 1.92 Newton per millimeter squared, okay, for your bond strength. If you are using a higher grade of concrete, then you know that you are also going to use a higher bond strength, like 2.21, if you are using, say, maybe M25. Okay, now the bond strength increases the resistance, or with respect, the bond strength increases with respect to the grade of concrete that you are using. Okay, so you see that if you are using a higher grade of concrete, it is better than using a lower grade of concrete. A lot of people don't really take this into consideration, but it is very important. Okay, so the only thing for you to know how to bring out your development length is just to master this formula. And if you know these different values in here, you can easily calculate it every time and you easily have it. Fy for yield strength, which is the strength of the rod. Theta here for the diameter of the rod is divided by 4 times the bond strength, the accurate bond strength that you have there. And when you have your answer, say after having this, if you have like say 200 millimeters or 300 millimeters or 400 or 250, it all depends on what you're going to have. Then you now know now that when you want to extend this rod, you know the accurate length of the rod that you have to extend, so it forms this hook, so that when you're extending now, you are sure that this beam is capable of sustaining whatever load that is going to be carrying, with respect to these figures that you have here. Okay, that is it for development learned. I hope you have learned something today. If you see from this little video that is displaying on screen now, you're going to see that this is an accurate display of what a good development length is all about. You see, as the rods are passed, they don't just end at the level of the beam, but they extend and they go into the pillar, and you only see that accurate lengths have also been provided and all that. Okay, thank you for watching. I hope these videos are helpful to you, and always make sure that you like and share these videos, because it motivates us to keep producing this kind of videos.